Hello everyone, it's great to be back. Today we are together for the launch of the 2024 S version of COMOSYS. It's an S version, which implies a mid-year small version, but as you will see, it's really quite a major upgrade. We've been working hard to provide you with world-class software at an affordable price, a real alternative to the mainstream. But we do more than just that. We always try and ensure that we have an edge in performance as well, so that your productivity increases and your company turns a greater profit because of COMOSYS. So we are hoping you will enjoy today's presentation. I've tried to condense it as much as I can so that your precious time is not wasted. Now, without further ado, I would like to start the presentation. So let's begin with frame handles. So we've added some frame handles, and which has made modeling a lot more convenient. So when you select a frame, previously there used to be an issue about recognizing where the start and what the end was. Now we have these handles, and if you see inside the square, there's a yellow dot, and the yellow refers to the start point. And if you come to the top, you will see that the same dot is pinkish over there. So the yellow is the start, and the pink one is the end. That's the first thing. The second thing is that we've added handles, like I said, and the handle I want to talk about is the first handle, the three handles over here: the arrow handle, the tail handle, and the pink dot in the middle. So the arrow handle, the tail handle, and the pink dot in the middle. What the arrow handle does is, if you select that and you give it a number, let's say you move it, it's going to extend the frame in the original direction by an amount, whatever you do. And this is going to actually physically move the element to that point. So the node also moves to that point. The second option is the tail option. And in the tail option, you get to actually choose the exact coordinates. So you could say minus 500. So it will not maintain the original direction. And let's say you want to do 150 Y. When you press move, it's going to physically move to that point. But now, previously, you could only move in the original direction, but now you can move in any direction. Third one, which is for basically adjusting without ruining the working point, is that you select the pink dot in the middle. When you do that, what you can do is, for example, say minus 150 in the Y direction. I'm going to bring the working point to the middle of the beam. I'm going to do that for this one, and I'm going to select the pink one over there and move that as well. If you notice, both of them are still there. The node is still there, but inside these numbers have been modified so that the working point comes to the middle of the beam. So the third handle basically allows you to do what adjusting them would have done. So that's a very useful way of working now. We have some improvements in the existing macros as well. So this is a moment resisting connection called the extended endplate connection. You're familiar with it. It used to work with 4 tension bolts, these pre-tension bolts around the flanges, but in some cases 4 bolts might not be enough. So we were requested to add these options of 8 bolts. So we have this 8-bolt option now, in which you have 8 bolts around the flanges, or you can have them in a vertical configuration, in which you have basically a vertical configuration like that with the stiffener. And this allows you to have more control and the ability to handle larger profiles as well. There are some new precast macros as well, precast concrete macros as well, which I want to showcase to you. The first one being the Corbell connection, in which a concrete column and a concrete beam are connected like this, where you create a Corbell and you create the reinforcing bars, you create these cutouts, etc. There's a plate. If I were to hide this, for example, there's a resting pad over there. You've got all the parameters to work with, the reinforcing bars, the additional parts over there, the Corbell itself. So it's called the Corbell Connection properties. You can have different configurations over here, for example. The 90-degree configuration, the 135-degree configuration, some other configurations over here as well. Very useful, very quick, very easy to use. The next macro is the ledge beam reinforcement macro, which you see on the screen. You have complete control over the strands. You can create multiple number of strands. You can give them exact XY coordinates, their count, etc. The longitudinal rebars, the stem stirrups, the ledge rebars, composite hangers, the end rebars, details, etc. So complete control. If I were to turn on the always on top rebar configuration, you will see that you have this complete control over the various strands and longitudinal rebars as shown in the figure. So very convenient, very handy macro. Once again, it's there for you to use. Next one is the inverted T-beam reinforcement for precast concrete members. Once again, you have complete control over the strand profile types. You've got type 1, type 2, type 3, type 4. You have individual control over the distances and the coordinates. The longitudinal rebars, once again, full control. Stem stirrups, ledge rebars, composite hangers, etc. And the whole thing. You can save your presets away, and you can use this macro in a very convenient fashion. And finally, the rectangular precast column reinforcement macro, which allows you to have control over the longitudinal rebars, the stirrups, the composite hanger bars, different direction details, etc., and also allows you to add strands. You can add as many layers of strand as shown over here, give their locations, and they will be added. So we have this neat little set. We're going to continue developing the precast macros, and we hope that in the coming versions the set will be much more complete. The next thing I want to talk about are modeless dialog boxes. This was something which was being requested by our users. And what it meant was that let's say we have a dialog box open. COMOSYS would not allow you to zoom in or rotate or select something else after the dialog box was open. But now in this new version, with the basic objects like bolts and plates and welds, you can zoom in, you can select something else, and you can make the modifications. So it allows you multiple modification from the same thing, and it allows you to zoom in as well. Now the same is obviously there with the plates as well. Not just you can have both bolt and plate dialog boxes open. You can zoom in at the background. You can keep selecting. So this is something which we've added to the basic objects. Like I said, you can even go to your profiles. So all of them can be open at the same time, and you can work with the objects. But it's not only that. We have modified it in such a way that all the steel macros now have these modeless dialog boxes. So for example, if I were to open this stiffened end plate one, you can see I can still zoom in. I can go and, for example, select this one, press M, enter, and I can even open the haunch at the same time, and I can still work with the background. So this makes working a lot easier. A lot of people are used to working in this fashion, and we've added these what we call the modeless dialog boxes across the board for the steel macros and the steel objects, etc. Now, I would like to talk about another very nice feature which we've added in this version. And this basically would interest those users which are working with pre-engineered buildings and tapered members, etc. Now, as you know, tapered members are very commonly used in pre-engineered buildings, and they have their own special macros and special connections, etc. Now, in these situations, when you model them as frame elements. As you can see, this whole built-up tapered member is modeled as a single beam. But in reality, it will be manufactured as three plates. Now, the problem with modeling them as three plates is that then these macros will not work because they work with a column and a beam or something like that, basically two profiles. So it's much easier to work with profiles, but when you finish the modeling, you have a problem that you want to get the drawings in the form of three plates rather than a single profile. So for instance, if I select this tapered beam over here and say show only, you can see that in the form of 3 plates, there would be this bottom flange plate, the wet plate, and the top plate. But right now it's modeled as a single element. Let me show all again, and let's select this and press the select assembly button, and now say show only. So this is the assembly which would need to be drawn in the drawings, which we need to somehow find a way that it is not drawn in the form of a profile, but in the form of 3 plates. To address this problem, what we have done is we have added another command over here under the Edit Frame menu. And if you come down, you have this new tool over here called Tapered Profiles to Plates. And what it does is it will convert the beam, the tapered beam, into 3 plates. But not just that, it will then reassign any weld or any bolt or any cut which was done operated on the original profile onto these new 3 plates. So you will get the same model basically which you have finished, but converted into plates. Now, obviously, to do that, it will need to explode these macros, these connections. So at the end of when the operation is finished, your macros will no longer exist, but your profiles will be converted into 3 plates. Now, to use the command, just select the profile under consideration, go to your edit frame, and press this tool over here, start this tool. It will ask whether you want to apply the cuts to the plate tips. What that means is that the ends of the plate sometimes need to be straightened, and that's in the original definition. You can turn them on or off. And whether you want to weld the plates or not, what that means is that the web and the flanges need to be welded because those welds have been shown at this point. So if you do want that, then you will enter the welding parameters between the flanges and the webs, and just press OK. And the moment you do that, your profile has been removed, and it has been replaced by 1 plate, 2 plates, and 3 plates. And all the existing connections have been reassigned, rather they've been exploded, and the parts created by those connections have been reassigned. The welds have been reassigned to these new parts. The cuts have been reassigned to these new parts. So, for example, if I were to select this plate over here and say show only, you will see that it has been cut according to the original profile. So I've got a very quick command, a very easy way now to basically convert my profile into plates. And if I were to see, although these are individual plates, if I were to select any one of them and say select the assembly, once again you see that the exact assembly is the exact same assembly as it was before, but now instead of the profile we have 3 plates. So that's very convenient. And of course, once we have the model converted into plates, we can continue by using the normal the numbering and the creation of assembly drawings, etc. And if you do that, for example, I've just created the drawing over here of that particular assembly which we've been talking about. And if I open it, you see that we have a drawing of that assembly, but this time it's not in the form of the profile, but rather you can see the individual drawings of those 3 plates as well. And if you go to the material list, once again, you will see that this plate and this plate and this plate, those are the 3 plates which have been shown separately in the material list as well. So a very convenient feature. Just with a single click, you can convert your normal profile into 3 plates, your normal tapered profile. By the way, it will also work with other built-up sections which are not necessarily tapered. So you can have a normal non-tapered section as well, and it will convert that into 3 plates as well. So very handy feature. We hope the PEB sector will like it in particular. Next, I want to talk about the plain cut command, which we've added in this version. If you open the cut menu under the edit menu, you will see that there are 3 more commands over here. plane cut by surface, plane cut by 2 points, and plane cut by 3 points. Let me begin by using the plane cut by surface command. It's basically very similar to the fitting command, but unlike the fitting in which the fitting command will extend the frame element to that plane, this one does not. This one just you can just assign a plane, and then if the plane cuts the element, that's fine. If the element is away from that, then it won't cut it, or it will cut it partially. So this is called the plane cut. Let's just use it. You click on the button and then you select the element which is going to be cut. So let's select this twin profile, and then it asks for a surface. So let's ask for the top of this bottom chord. And when I do that, immediately, let me right click and finish. Immediately this little, it looks like a fitting, but it's a plane cut in the sense that it will cut this element at that point, at the top surface of that element. I can continue to use the same command. For example, I can say plane cut by surface again. Once again, I cut the same element, but this time I use the front face of this vertical member. When I do that, I get another plane cut, which is this one. And now I can use it a third time to fit, or to cut rather, this one with the top of the bottom chord. So let me do that again. Let me say plane cut by surface, this element, and I select the top of the truss once again. And when I do that, now another cut has been created, and now all the clashes have been removed. If I turn off the cuts, you can see that basically that joint has been cut according to the situation. Now, to explain the difference between what I just said, between this new plane cut command, which has 3 versions with the surface with 2 points and 3 points, and the fitting command, which you already know, let me use the fitting command with 2 points over here. So let me select this element, select the side which is going to be fitted, and then select this point, and use the fitting command. Now you will see that once I do that, this element is extended into that line. It was originally over here, and it was extended so that it gets cut. It gets extended to that point. Let me undo this, and now use the new command, which is the plane cut command. Let me use the same version, the 2 points version. So let me select the element, select the 2 points, and show the side. And this time, if you see, it has just produced this plane over here, and the element has not been extended to that point. If it cuts, it cuts. If it doesn't cut, it doesn't cut. That is the basic difference. Now, another difference between the previously existing fitting command and this new plane cut with surface command is that this new command does not only work with profiles, but also works with other objects like solids or plates, etc. So the earlier command fitting would only work with profiles, but this one works with all objects. So let me just try this surface command once again. Let me cut this sphere, which is a solid element, and let me choose a surface. So I've chosen a surface on another object, and when I do that, immediately this cut is created, which basically cuts this sphere along that surface, which I had selected from the other element. Now, if you double click on this plane cut, you have this option of reversing it. So if you press the reverse button, then the other side is cut. Previously, it was cutting this side and keeping this side, but now it's keeping the other side. So you can always go back in, double click on this one, and reverse the direction of the cut if you want to. Other thing which you can do is you have this offset over here. So if I were to give it an offset of 50 millimeters, for example, if you see on the screen, if I say apply, it moves slightly. So let me give it a bigger one, 250, for example. You can see that the cut is being moved 500 millimeters along the outer unit normal direction of that plane. I can always bring it back to 0, where the original definition was. And of course, the cut dynamically changes itself. For example, if I were to double click on this sphere and make it slightly bigger, maybe make it about 7 meters in diameter, the cut will automatically adjust according to this new size. Once again, it will always be cutting along that plane, which we selected originally. So like I said, this command works with plates as well, unlike the fitting command. So I can just go and select the command again, select this plate, it's folded plate over here. And as a surface, as a limiting surface, I can use this inside surface of the angle. And when I do that, this hole, it sees the bounding area of this entire plate and cuts it accordingly, cuts both sides of it, as you can see. Now, if I turn on the handles, you will see that it's got 3 handles, which basically define the plane. And if I want, I can select these 2 handles, for example, this one and this one. And I can now even, if I were to move it, I can say move, let's say in the Y direction. I can give it a small offset of say 20 millimeters. If I say move, you will see that the plane, the cutting plane is being moved. And now if I were to show this only, if I say show only selected, you see that the end has been cut at an angle, unlike the original case where, so now this plane cut is now slightly inclined. So I can use the handles to move the plane around as well. And as you can see, it cuts both the profile, the solids, the plates. So that's another major improvement. Now, as a final comment on this command, I would just like to remind you that when you're using it from a sectional view, for example, if I wanted to use the plane cut by surface, and I want to cut this member, so I select it, and now it's asking me to cut to select the surface, and I want to select the top surface of this bottom chord, but I can't select it because I'm working from the sectional view. So all I need to do is just come over here as close to it as I can and press the control key. It will flip to that section. You still won't be able to see it, but it is flipped. And now if you just press the left mouse button, you will see that it has selected the correct surface to create the plane cut. For example, let me do it again. Let me select this one, and I want to select the side of this vertical member. I can't select it. I just hover over there, press Control. Now I'm sure that it has selected the other one, and I press the left mouse button. Once again, if I want to cut this element with the top of the bottom chord, I hover over the top, press Control to make it flip, and just press the left mouse button. As you can see, those 3 plane cuts have been created very easily from the sectional view. Now let's move on. Once again, there's a little more to say about the cuts. You're already familiar with the polygon cut, but we've completely rewritten it in this version. And now you have several other options which weren't available previously. So if I were to use the polygon cut command, you know how to use it. You just select the element, and then you select a few points to define the polygon. So let me start from there, then say dx 150. And then on the new point, I just hover over that. As you know, I press enter, say the Z minus 150, go down. I hover over this one now. I say dx minus 150, and then I can just go back, close it. Now, when I do that, you're familiar with this polygon cut, so nothing new over here. But when I select it, you can see that now we have these handles available, which weren't previously available. The first thing I want to show you is if I double click on this, you can change the depth, the default depth. So it's created with a default depth of 1000. You can make it 175, for example. And the depth can be modified. I can even make it smaller. So if I make it say just 75, I can make it actually smaller than the flange width of this particular member. Let's go back to 175, which is better. And the much more important thing over here, of course, are the handles. And the handles can now, so I can select this edge, for example, and I can press this button and give it an offset of 50, for example. And the edge will move in its perpendicular direction. I can select it again. I can move this edge. If I want, it'll go down. I can select the thing again. If I select this chamfer point and I go to the chamfers, I can select type 3 chamfer, maybe that's better. And I can say, give it a chamfer of 50 millimeters. And now I have this chamfer of 50 millimeters over there. let me turn it on again. So you see, you have all these handles. The corners can be selected, the edges can be selected and moved, the corners can be selected and moved. You can even move it along by using these arrows. You can move it along the arrow directions. So very nice features for the new Polygon Cut, which I'm sure you'll find very useful. The next thing I want to talk about are custom macros. Now, those of you who are familiar with COMOSYS will already know that we already have this feature called user-defined macros. But user-defined macros, as you know, have a limitation, and that is that once you define a macro, it only works in situations where the main member and the secondary member and the orientation and the approach angles are exactly the same as the source definition. If they're different, then the user-defined macro will not work, or it will work, but it will not produce the results according to the situation. With this version of COMOSYS, we are introducing what we call custom macros. And with these, you will get a new ability where you will be able to define your own macros, and not only define them in a dead way, but you will be able to give them intelligence, which means that they will adapt whenever the main and the secondary profiles or their orientations or their approach angles change. Now, the first step is to use the custom macro wizard, which gives you several options, like you can create a connection or a detail or an end detail, like a base plate, for example, or a seam, or even a custom part, which is standing alone in space. Once you're done with that, you can give it a name and you can give it a location where it will appear in the component manager. Once you've done that, the next step is to simply add the parts which have been created by the macro to the definition. And after doing that, what you will do is you will then add the dependents, so the main column and the secondary beam, for example. And in the final stage, what you will do is you will take a snapshot, which you will then use as the icon of the component which you are developing. Once the definition is done, what we do is we continue to the custom macro browser, and this is where you get a summary of all the main parts and the parts which have been created by the macro. Now, if you were to open up this tree view, we will see that we have all the details of the main parts. At the top, we have things like the material and your drawing groups and your class and your color and your part prefixes. And you also, in the bottom part, which is the part properties, you have things like your position in depths, position in planes, rotation offsets, section parameters. Using this custom browser, you will not only be able to get these properties of the main dependents, but also set their values depending on the parameters entered. And then similarly, you have complete access to the created parts, which means the plates, the bolts, the welds, the cuts, and you have access to their individual properties like the general properties and part properties and chamfer properties, etc. Once again, you will be able to get these values and you will be able to set them depending on whatever the needs of the user are. So you will be able to set all the properties of the created parts. Now let's move on to the most important concept of bindings. With bindings, you can now associate the handles of your created parts to either the dependent parts or the created parts themselves, which means that the handles can move when the planes of these parts move. As an example, let's bind the 8 handles of this fin plate to the web of the secondary beam coming in, and see that how when the secondary beam moves, the fin plate will move with it. As you can see, despite the fact that the macro was defined with the secondary coming at a 90-degree angle to the main, now that we move it to an inclined position, the fin plate adjusts very nicely. Now, of course, these handles do not have to be glued to the planes with a 0 distance. In fact, what you can do is you can control the distances by using variables inside the macro, as you can see on the screen. As you can see, when we move the secondary beam down a bit, the entire fin plate adjusts accordingly, while also maintaining the distances from the bottom and top flanges of the secondary beam. Now, while bindings are very useful, they truly come to life with variables. And with variables, you can do so much more. There are three types of variables: custom variables, binding variables, and also object variables. And by using the custom variables, you can really control how the bindings will behave and how the objects will behave. Now, the custom variables, which are over here, for example, can be defined by either using formulas, which can include other custom variables. So, for example, you could write bolt y dist plus shift, something like that, including the other variables. Or you could just call some functions which are available inside the custom component, custom macro editor. So by using functions or formulas including other variables as well as functions, you can basically do anything you want. So if you're wondering what kind of things can be done with this new capability, here is a base plate with many plates in it, and with using the custom variables, we can access the properties of these plates, move them around, give offsets, as you can see on the screen. Very conveniently, we can make a very useful macro out of it within an hour or two. The bindings have been created, the object variables are accessible through the form, and everything moves together with the dependence. Perhaps you're interested in a much more difficult example. Once again, the bindings are extremely easy, and also adding the custom variables. And these custom variables then allow us to change the plate thicknesses, the interbolt distances, the edge distances, other edge variables. And if you want, we can change the size of the column or relocate the beam to a skewed position. Once again, everything works. Now, let's try an angle pleat connection. But instead of using angles, let's use folded plates, because with folded plates, we don't have the connection available in the standard library. Once again, as you can see, you can enter the parameters, the bolts, the edge distances, everything changes beautifully. And if you move the end point of the beam, once again, the skewed connection is also made in front of you. Now let's do an example in which the number of created elements actually changes according to the lengths. So let's change the width of the lower landing, the upper landing, the length of the stair, the height of the stair, and then the width of the staircase. And you can see everything is adjusting perfectly. Now let's do an example about getting data from text files. So this is a very simple example in which there's a column and there's some threads coming out of it. And you can change the main column profile. For example, you can choose a different one, press apply, and it's going to be a different profile. But the point over here is this ladder name, which depends on a file. So there are three types of ladders inside it. Now, if you go to the text file, you see it uses a text file called ladder types. And if I open that file, it's got three ladders inside, and the column height and the number of threads is given over there. So using this file, if I just choose the type of ladder to be 1, and I say apply, a different ladder is created with a height of 5 meters and 5 threads. If I choose ladder 2, I can increase the height and put more threads on that. So a very simple example just gives you an idea that you can use data read from files directly through these macros. And as you might have noticed, the dialog box for these custom macros is completely customizable as well. You can access it from the custom macro browser just by pressing the form editor. And when you do that, the complete editor for the dialog box appears in front of you. And here you have access to adding new tabs, deleting new tabs, adding weld variables, bolt variables. For example, this bolt tab, this entire set of bolt parameters can be added by just pressing a button. Similarly, for the plate tabs, automatically you can get these variables assigned, or you can do them manually as well. You can add pictures, color boxes, basically anything you want, edit boxes, labels, completely customizable, very easy to use. Just save it away and it'll give you a very nice dialog box to play with. Just imagine the power this gives you. A particular unique connection is not available off the shelf. Just create it in a matter of hours. And not just a dummy connection, but an intelligent one. Save it away for future use in your company and in other projects. Isn't that wonderful? It's basically parametric modeling at your fingertips. And we're now adding some very special capabilities to this parametric modeling engine. When you use it, you will be pleasantly surprised at how little you will need to do. It'll just work magically. So stay tuned for even more on this in the coming months. It's going to leave the competition in the dust. Now, I want to talk about a very important new feature which was being requested by many of our customers, and that has to do with custom environments and the Imperial Units on the modeling side. So let's begin by Imperial Units. So if you remember, on the bottom right-hand side of COMOSYS, there is the Units menu over here, Units option over here. And previously, we had millimeters, centimeters, meters, kilometers, inches, and feet. We also had these, which are Imperial Units, but these were in decimal format. So, for example, you could not say 5/8 of an inch. You would need to divide 5 by 8 and put that number in decimal format to give you the exact value. So we are still retaining those two, pure inch input in decimal format, pure feet input in decimal format. But then we have another unit. This is a special unit over here called feet inches. And this one allows us to enter whatever distances which need to be entered in the fractional foot inch format. So let's see what that means. So currently I have my units in millimeters. If I double click on the grid, you see it's 4 times 6,000, 4 times 6,000. That's the default. But if I go into this units and convert it into the feet inches, this format. Now this is the fractional format. If I do that, and now I double click on the grid, those 6,000 millimeters are now converted into feet and inches. So it says 0, 4 into 19 feet, 8 underscore 7 over 32 of an inch. Now we have the underscore over here. Normally you won't be required to do this, but this is only required in places where you can have multiple inputs separated by spaces. So in those cases, you have to fill the space with an underscore. So for example, if I were to say 4 into 22 feet, let's say that. Now in the x direction, I've got 22 feet going like that. For example, if I were to measure the distance from here to here, it says 22 feet. At the top, it says 264 inches, 0 inches in the y direction, 0 inches in the z direction. Now, whenever you do that, you'll get an answer like that. Let's change the y direction as well. So 4 into, say, 16 feet, for example. If I press OK, I change my y direction. If I double click again, if I say 22 feet, and then I say 6 inches. 22 feet, 6 inches. If I do that, it's slightly increased. So it's 22 and a half feet right now. If I wanted to say 6/3 over 1/8 of an inch, in that case, I would put the underscore sign and say 3 divided by 1/8 of an inch. That would move it slightly more. So this is a convenient way of inputting your distances in the feet inch format. Now, in principle, this feet inch format, because it's a fractional format, it's kind of limited in its accuracy to 1 over 32 of an inch, which is less than a millimeter, so it should be fine. But let's say you wanted to have a much more exact grid distance, so which is an exactness which is more than 1 over 32 of an inch. In that case, what you would need to do is not use this one, but actually go to the actual inch system, for example. And when you go to that one, then the numbers are converted into decimal. As you can see, it says 4 into 270.375 inches. The moment you go into the inch system, it will be you lose the fractional input method, but now you can actually go and say 37557 inches if you wanted to. Now that will obviously change it to that exact value. But if you go back to, and I mean not for the grid, but if you when you're using other commands like copy and move, you need to understand this point, that if you need an exact thing, which is like exact to the 10th decimal place or something, it's better to go into inches and feet. But if you want to use the fractional one, then you use that one. Now let's do an example with a frame. For example, let's put a column over here. If I double click on that, I'm in the feet inch system at the moment. It's brought the numbers in the feet inch fractional system. Let's say I want to make it 20 feet. Immediately the column is raised to the 20 feet level. If I want to say 20 feet and 6 inches, I can do that as well. Rises up a bit more. Let's do a beam example. For example, put a beam over here, and its position and depth is behind. It's behind 0. If I give it an offset of 6 inches, it's going to move 6 inches behind. So these numbers will work in the fractional system, but these offsets over here, we have forced them to work only in the decimal system, and the reason for that is because these usually need to be very accurate. So it doesn't make sense to enter these numbers in the fractional 1 over 32 or 3 over 8 or whatever. It's better to leave them. So whenever you're entering these numbers, it's going to directly go, even if you don't change it from here, it's going to directly go to the decimal system for these offsets. So for example, if I were to enter a number over here, I know it's automatically going to be in the decimal system. So if I say 12.37654, it's going to take 12.37654 inches as that number. And if I do that, the offset is extended to the exact amount which I want. So over here, I don't even need to say the quotation. I just need to enter a number like I'm entering in the normal decimal format. It will always be in the base units, which is inches. Similarly, with the plates, I can enter if I have my feet inch units installed, I can enter my thickness as in the fractional format. So 5/8 of an inch, it's going to become 5/8 of an inch like that. And similarly, your offset can also be entered as, for example, half inch. If you want to, you could do that. It's going to move it half inch forward. Now let's use the copy command, for example. Let me select the plate and the column, right click, say copy special linear. And as you can see, because I'm in the feet inch system, it's bringing me some numbers over there. I can say go 6 feet, say 5/8 of an inch. I'm sorry, I didn't write that correctly. 6 feet 5 divided by 1/8 of an inch, and make 2 copies of that, or 2 copies of that. If I do that, my column is copied, and if I were to go and measure, if I say measure distance from here to here, you can see it's 6 feet 5/8 of an inch. Now, if I had a more exact copy, which I needed, I could go to my inch system, for example. So let me undo this, go to my inch system and select this or both of them, and just go in and say, for example, 75.5755 inches. Now, in this case, I don't need to give the single quote because these systems are in decimal format. And I got 2 copies of that. If I copy them, these are copied 75.5755 exactly. And if I were to measure the distance, you can see that this is going to be 75.5755 inches. So that's very handy. Even the direct entry system, which is very popular in COMOSYS, will start taking the input in Imperial Units once you select the feet inch. So for example, if I select the column command and hover over this point, press enter, and say dx 2 feet. It's going to put the column 2 feet from that point. Similarly, if I were to, for example, let's say I put a column over here and a column over there. Let's just put it like that. And I put a beam from here, and then I cover over this point and I say BZ 25 feet 6 inches. The beam is going to go to that point. So the direct entry system also starts taking the input in the fractional system if you want. Similarly, in the macros, once again, you can use your either the fractional or the decimal system when you're entering the inches. So for example, here, if I feel that this cleat is too far from the top, I can maybe say it's 5/16 of an inch, a little less than an inch. Apply, and then to see whether I'm clashing with the radius, I can go to this new feature. I can say draw the exact shape, and I can see that I'm okay over there. So once again, your dialog boxes as well, your macro dialog boxes as well, will have this option of the fractional and decimal input systems. Now let's talk about the environments option. If you go to your Explorer and see that under whatever structure you have, under Program Data, Proya Software, and COMOSYS 2024, you will see these directories. And I'll be talking about two of those directories, the environment directory, environments, and one is company settings. Now, with this version, we are providing you with lots of factory default environments. So if you see over here, it says there's a default one, then there's several, Australia, India, Russia, Turkey, and USA. And these are all under this environments directory. And inside each of them, there's a whole list of, all sorts of settings and presets and profile databases and bulk databases. Everything basically to do with that environment is under each of those directories. Now this is the environments directory, and this is the one which is like out of the box. These are factory settings, so you're not supposed to play with these files. What you can do is use any one of these to clone your own environment. So for instance, if you're a company doing business with the USA and doing business with, let's say, 3 different companies from the USA, and each of those companies has different, let's say, drawing standards or whatever settings or defaults or databases or whatever it is, you can create 3 new environments based on the USA default environment, and then basically customize each one of them and save them away. Where do you save them away? You save them away in your company settings. And if I double click on the company settings, you have only the default directory with the standard setup, but you could create as many new environments, copies of environments, or environments based on the US or based on the Australian or based on whatever default environment. And you can keep adding those, you can clone those environments over here. So this is a very handy way of building up your own environments. Now, while the name of this directory is hard-coded as environments, the name of this particular directory, company settings, will depend on your local ini files. So just check your COMOSYS ini file over here. If I double-click on that, you will see that over here you have the company settings directory, and over here you give the name of the folder. So whatever name you have over here, that will be the name of this folder. So now let's delve a bit deeper. Like I said, each of these directories have the environment information inside them. So let's double click on any one of them. There's one folder inside called catalogs, and this folder will have the profile catalog as well as the bolts catalog. So whatever you're modifying or customizing, it will be saved under these 2 files over here. These are the primary databases. If I come up, the next one is preferences. And in this directory basically lie all the default settings of the macros, the presets, the tools on the modeling side, the various commands on the drawing side. For example, all your, for example, your dimensioning, the dimension parameters which you have for your drawings, what kind of style you're using for dimensioning. All those informations are under the preferences directory, and as you can see, there's a lot over here. They're related to the drawing module, like I just mentioned. They're related to macro settings, macros, mechanical objects, report templates, general settings, structural objects. I mean, I'm not going to talk about the details over here, but basically everything, anything and everything which defines the defaults and the settings of all the commands on the modeling side or on the drawing side are all under this preferences directory. Now let's see those directories from the user interface. If I were to go to my file menu and come down to the settings, these general settings open up. And on the right-hand side, I have this tab called environments. And inside the environments, if I go, you have the environments for new models. What this means is that any new model which you make will be based on the environment you choose from here. And what do you get from here? You basically get only one. And this is what we just showed you, the one over here under the company settings. We only have the one option right now, the default one. So this list is very limited at the moment. But over here, you can create more environments, and you do that by cloning based on some existing factory one. So let's say I wanted to clone the USA environment, make a copy of that. Like I said, these are factory environments, and you can't spoil them or add anything to them. They will stay the way they are, but you can clone them. So when I say clone, it asks for a name, and I can give it a name of, say, company one, based on the USA one. And if I press OK, it's going to take a few seconds because it's copying a lot of files into those directories. And then it's going to give you a message saying the environment has been cloned successfully. And when I press OK, now I get that company one option in my in this list as well. So if I select this one, for example, what it means is that once I press OK, any new model I create will basically be based on the company one USA environment. Now, like I said, once I create a new model, let's say based on company one USA environment, I can then continue to, for example, modifying the databases. Let's say I could add some new profiles or add some new bolts, or I could make some changes in the default settings on the drawing side or something. Now, whatever changes I make after that in that model, whatever changes I make to the settings, for example, when I save them, they will not spoil this company one USA environment. All those changes will be saved only in the local model directory. So whoever is creating that model will basically save it for himself. And the reason why we do it like this is because we don't want somebody to spoil the company environments. If you do want to, at some point, do it, you will need to copy it manually from some local folder or do it in a more controlled way. But by default, we allow you to make clones of the factory environments, save them away, and then new models are based on that cloned environment. If you want to check what environment this current model, which is open, is based on, you go to this model directory over here, click it, and over here it will tell you which environment this particular model is based on. So you can find out, let's say you receive a model from somewhere, you can find out about its environment. Now, what if you receive a model from someone and you open it and you go over here and you see that it is based on a certain environment, but your own local installation does not have that environment amongst the available environments. So somebody has created a new environment, done a complete model with it, and they've sent you the model, but you don't have that environment. So in that case, what you will need to ask them is to provide those directories which are their environment directories, and then copy those environment directories in the company settings folder. And then when you open the model, you will be able to work with it. Let's start with a few words about IFC, the industry foundation classes. So in this version of COMOSYS, we have added, if I double click on this plate, for example, an IFC tab to all the objects. And in this tab, you find this new ability of defining your IFC entity type. So it could be IFC beam or a column or a wall or a curtain wall or a slab or a stair or a ramp, plate, footing, etc. You've got several options. And this allows for better organization on the viewer side once you export, and whoever receives it can organize the data better. So just assign the relevant entity types and IFC will be exported accordingly. Similarly, you can give it a building name. So this also allows the other side to organize the information better. And you can give each part a story name as well. And that will, of course, once again define the various stories on the viewer side. Another thing which was needed was that if you go to the project settings over here, we now have the ability to define base points. This is also for the IFC export feature, which means that normally when you have a large plant or a large facility, you've got many buildings in the same facility. And usually the modeler will model them at the global 0, 0, 0, XYZ coordinates. But the actual building, as far as the site coordinates are concerned, is somewhere else, and it probably has a rotation angle as well. So this definition of base points allows you to define the origins and the rotations and the east and north and elevation, these coordinates for your building. And although you will model it locally at the 0, 0 level, but it will go to this shifted position, shifted and rotated position in the viewer. And you can create as many base points as you want. It comes with the default base point, obviously at 0, but then you can add base points. And when you do that, these base points will appear in the IFC export dialog box. So this, for example, is the IFC export dialog box. If you see you select a file name and do your settings, etc. But then you have this option of base points, and you can choose any one of the base points you have just defined in the other from the other place. And once you do that and you press export, your elements will be exported to the correct base point.
The next thing I want to talk about is the new feature in which we allow the export of the COMOSYS model to the IDEA Statica connection design software. Now, as you know, COMOSYS already has design capabilities in with certain macros. But in order to generalize it, in order to make it available for any kind of a connection, what we have done is we have created this export to the commonly used software, IDEA Statica. And to do that, we start off by going to the File menu, and under the Import Export tab, and under the Export option, if you go right at the bottom, we see the Launch IDEA Statica checkbot. And when we click on that, immediately this checkbot is launched. Now, once the checkbot has been launched, you can choose your design code and your project type over here. The name is automatically given by using the name from the COMOSYS model file, which is open at that time. Now you just press the Create Project button over here. Let's do that. And we have the project created. Now, if you look at the top left over here, you have these two options called bulk and one. And the meaning is that one basically means it's a kind of a detail, which means things like base plates, for example, when there is only one primary main member, and the rest is just part of the connection. Or a bulk would be in it's a classical connection with at least two or more incoming profiles, and the rest is the plates and the bolts. So let's press the bulk button over here. When we do that, this thing comes up saying awaiting user selection in COMOSYS. So if we go to the COMOSYS program right now, it's basically waiting for us to select from the screen. So I'm just going to go like that and select all the members and the parts which are in the connection, and just leave it like that, and right click. Now, when I do that in the checkbot, the initial connection is created. It's given a name over here, and you can keep importing more connections into the checkbot from the same model. But at the moment, we've just imported one of them. And if I were to press this C204, which is the name given to this connection, it will take me to that connection. So I have the C204 connection over here. If I press open, it will open the IDEA Statica software and take us there. Once you're here, it will give you certain warnings, which you can see. So maybe you need to go back and modify certain things. But over here, it allows you also to move your connection around and see it. And once you're happy with the connection, if you're happy with the final configuration, you can go ahead and use IDEA Statica as you would normally do. Now, the reason it was giving me these clashes and warnings was because I had forgot. If you see, this beam is penetrating into the column, and the reason why that happened is because if I go back to COMOSYS, when I was selecting these members like that, I had forgotten to turn on the cuts, and the cuts need to be selected as well. So don't forget that. You need to select all the members in the connection for the export to work properly. But if you do that, you will not have any such issues, and you will get your connection, which you can then continue working with. Now, the next time you launch the checkbot, let's say after a couple of days that you have another connection or some other time, it won't ask you for the project details because the project has already been created. You have one connection inside it. Let's say you want to add another connection to this project. You will once again choose one of these, bulk or one. Let's choose one this time. And it says awaiting user selection from COMOSYS. So we move to the COMOSYS side. Let's say we have this base plate to analyze. We just make the selection. Just make sure you can select easily at this point and right click. And when you do that, it will take you back to your checkbot. Once inside the checkbot, you will see that you now have two connections in the checkbot. This was the one you created earlier. This is the new one, and you've got them both listed over here. Just once you select the one you want, you can press open, and it will open the IDEA Statica software for you. This time, as you can see, there are no warnings because we imported everything correctly. You've got all your plates, your welds, your column. So the base plate is ready for you to now start working with. So this is a very nice new feature. Let's say you create your own custom connection. It's very complicated and you want to analyze it. Just create the connection. It can be as complicated as this or even more. And just export it to IDEA Statica and get your results from there. So very, very useful. We hope you will use it a lot. Next, let's talk about Grasshopper. And in this version of COMOSYS, we've added several new features to the Grasshopper integration, which we have. Over here on the left-hand side, first of all, you see this menu, the COMOSYS menu inside Grasshopper. And once you click that, you have these options. And over here, you have all the different types of structs which we use, which I've listed over here. So things like your weld line struct, things like your this is related to the the welding struct, the numbering struct, for example, your part prefixes, your numbering prefixes. This is the rotation angle of the profiles you will create, the coordinate system struct over here, the drawing related variables, things like exclude from dimensioning, do not annotate, and formwork group. These are very important variables which you might want to integrate. Your position and depths and your position and plane variables, your rotation variables, similarly your end offsets, all these basic structs which are used inside COMOSYS. And as far as the objects go, we've added several more. Previously, we had only integration with profiles and plates primarily, but now the generic solids, extrusion generic solids, the general generic solids, which can be basically any shape, and also your rebars and grids have been integrated. So you have a lot of control now, and you can basically create almost any kind of shape which you want. So as a very simple example, here I've just made an outer polygon curve. I've made some inner polygon holes, and there's a path of extrusion. So this is the path of extrusion. This is the outer polygon. This one is the inner holes. I've plugged them all into this one over here, which is the generic solid with extrusion. This one over here. I've just plugged these in, basically the coordinate system, the path, the outer polygon, and the holes. And if I just go back and I have a live link with my model. If I press bake and go to COMOSYS, which should be open at this point, my extruded, very rough bridge section is created, as you can see on the screen. Let's just tweak the path a bit. So maybe I can move this point up and move this one down a bit. What about these two? Maybe I can bring this closer over here. Bring this closer like that. Once again, I just go back in, right click, say bake, go to my COMOSYS window, and the new different path has been used for the extrusion. So very convenient. You all know what Grasshopper is capable of. Now you can use all those capabilities to set up your very complicated roofs, bridges, facades, or anything with a difficult geometry.
Well, that's all for today, folks. I hope you liked what you saw. The version I presented today will be available for our customers from the 10th of November. The trial downloads will also start at that date. And as soon as that's done, we'll start on the next version. With COMOSYS, you will not see stagnation. Every release, major or minor, will be fun-filled. We like to keep our customers happy and try as much as we can to respond to their demands. Much more than our competitors, we are told. So stay tuned for even more. Now that the launch is over, we'll be returning to our training webinars. Do join us in those as well. They're a great opportunity to learn the program firsthand from us. It's basically free training for your people. At the end, I would like to say that please get in touch with us or our resellers immediately. Some attractive price offers won't be lasting too long, and it's the right time to take the big step. See you all soon.